Welcome to Separable Differential Equations. It's a topic that we often see in college level calculus courses. It's sort of like the first encounter with differential equations. A separable differential equation is a differential equation of the form dy of x dx, the first derivative of y with respect to x, equals a function of x times a function of y, or can be put into that form. The technique is to first find the constant solutions by setting gy equals 0. Then we separate the equation dy over g of y equals f of x dx. Integrate both sides of the equation. The integral of 1 over gy dy equals the integral of f of x dx. And we would solve that for y if possible. In some cases, it'll be impossible, and we will just do the best we can. So handle any initial conditions. An initial condition would be a way of finding a constant of integration. So we're going to solve a simple differential equation. The derivative of y with respect to x is x squared plus 2x multiplied by y squared, where an initial condition of y of 1 equals 2. The constant solution from y squared equals 0 is y equals 0. Next, we look at the separated equation y to negative 2 dy equals the quantity x squared plus 2x dx. We integrate both sides. The integral of y to negative second dy equals the integral of x squared plus 2x dx. Well, here we have all y to the n, x to the n type equation terms. So y to the negative second power, the integral of that becomes negative y to the negative first. And x squared, integral of that becomes x cubed over 3. 2x, the integral of that becomes x squared. And we'll put the constant of integration on this side. There's no real value in writing two constants of integration because we would just merge them into one constant eventually. So solving, we take the negative reciprocal of negative y to the minus 1, and we find we have y solved. And that gives me the negative reciprocal of the other side. We need a least common denominator of 3. So we would have 3 goes into the numerator, and x cubed, here we would need 3x squared. And here we would have a different constant because we're having to adjust for the least common denominator. Now we would use the initial value condition, y of 1 equals 2, to find C1. So we plug a 2 in for y and a 1 in for x. So we get 2 equals negative 3 over 1 plus 3 plus C1. So C1 is going to be negative 11 halves. Y then equals negative 3 over x cubed plus 3x squared minus 11 halves.